Good day, everybody. This is Mrs. Peachy, and I'm recording a tutorial for your Circuits and Electricity portfolio for physical science. So I hope everybody is doing well. I'd like to turn your attention to the screen below me here. And as you can see, the lab is entitled Building Electrical Circuits. And we're just going to be following the lab as written. You do need to use a gizmo here in order to be able to kind of see what's going on. And ultimately what you'll be turning into me is this bottom sheet, the Building Electrical Circuits lab sheet. So I can bring that one up here on the screen. And kind of see here is very long. There are a few questions about Activity B, series circuits, and a few questions about Activity C, parallel circuits. So this is what you're going to kind of do after you're done with the gizmo. It's more of a summary sheet. While you're working on the gizmo, you're going to be completing a different sheet here. Where is that one? This one. So this is going to pop up the student exploration sheet when you go to the gizmo, and this is going to give you the directions, what to do, questions it's going to ask you and stuff like that, but I don't want you to turn this one into me, okay? So going back to this page in your lesson viewer, if you just click on the link that says circuits, it'll take you to the gizmo. Okay. Now if you want that student exploration sheet, that's going to be at the top of the screen. And I'll just move myself down a little bit here, but under lesson info, you'll see the student exploration sheet, and that's going to give you kind of the directions, what to do, and that kind of stuff, okay? Because you're going to need that, otherwise you won't know what it is that it wants you to do. So bringing that up, I'm going to go to Activity B, and I'm going to see what does Activity B want me to do. It says, get the gizmo ready. Click Clear, create a circuit as shown right here. So that's my first step, is to create this circuit. As you can see, there's a battery, positive end on the top, negative end at the bottom, a switch in the off position, a light bulb, and some wire. Now it does tell us in the directions not to do Activity A, so we don't need to do that. So going to the gizmo, all you need to do is to click and drag these things into place. This one's going to allow us to flip it upside down. There we go. And there was a switch over here, which I'm going to turn off right away. These are pretty easy to put together. Just click and drag and click and drag. Alright. Now I'm going to compare this to the one that I was supposed to do. Looks pretty close. Mine's a little bit more square, but I'm all good with that. Now it says turn the light switch on and observe the light bulb, and then start replacing the wire segments with new light bulbs. So basically, I'm going to turn this on. I'm going to see the brightness of the light bulb, and then I'm going to find out what happens to it if I add a second light bulb. I don't need to take the wire away. All I have to do is drag another light bulb over top, and it will replace it. So just add additional light bulbs and observe the light bulbs and tell me, what do you see? Okay. The second thing says use the ammeter to measure current in various parts of the circuit. So when you're using the ammeter, This one's pretty easy. You just have to plunk it in a spot and it'll measure the amperage right here, 0.22. Okay? You don't have to do anything else but just plunk it around and write down what the amperage is in different areas. That one's an easy one to do. And then you're going to talk about it, form your hypothesis. And then it's going to ask you to make a series with a 10-volt battery and 4 10-ohm resistors. It says, based on voltage and current, what is the resistance of the circuit? So you need to look at Ohm's law to determine what you think the resistance of the circuit would be with 4 10-ohm resistors. Now it says measure the resistance. Remove the battery and attach the terminals of the ohm meter to the ends of the circuit where the battery used to be attached. So you're going to have to do, to make this particular circuit, first you hypothesized what the total resistance was. Now you're going to take away the battery and you're going to put the ohm meter in place. You would place the other O right on this other spot there, okay? And that's going to tell you the resistance. But I'm not going to tell you that. You got to do that part for yourself. And then it says make a rule. How can you calculate the total resistance of a series circuit? Okay? So this first one, based on voltage and current, what's the resistance? Ohm's law, remember? Ohm's law. I equals V over R. Ohm's law. I equals I equals V over R is 1. So that would give you resistance. No, that would give you current, excuse me. So resistance would be V over I, voltage divided by current. Okay? It helps to have a nice version of Ohm's law. Okay? And then extend your thinking. Replace the battery, turn on show current, and remove 1 resistor. Why would it be a problem if your household appliances were connected in a series circuit? So you're going to go back here, put the battery back in place, turn it on, show current, and let's remove 1 of these guys. I see what they're saying. Sorry, I misread that. So you're pretending like these are household appliances. Toaster, blender, microwave. Oh, I'm going to unplug my microwave. What happens? Well, toaster and blender won't work because these are all connected in series. Okay, so don't like the wording on that row as much. Then we do activity C, and activity C is using parallel circuits, creating more than 1 path. So you're going to set it up like this. select the battery voltage to 15. So to do that, you gotta click on it, and you're gonna have to use this little slider to change it up to 15. Okay, gives you a little bit more energy there. Now it says turn the switch on, then add 2 more light bulbs. How does each new light bulb affect the others? Use the ammeter to measure current in various parts of the circuit. Is the current the same throughout? Explain. Form your hypothesis. How do you think the total resistance of a parallel circuit is calculated? Then you're going to experiment. You're going to leave voltage at 15 volts. You're going to measure the current in parallel circuits with 1, 2, 3, and 4 bulbs. In each case, place the ammeter next to the battery. Okay, so use Ohm's law to calculate the total resistance of the circuit. So you're going to do this 4 different times. The first time, the whole circuit only has 1 bulb. The second time, the whole circuit has 2 bulbs, 3 bulbs, then 4 bulbs, okay? And what you're going to be doing is you're going to actually place your ammeter right here. Well, I can get it right here. Okay? And remember, you're making a parallel circuit. Here's my 1 bulb. Yeah, probably don't want to do that. Two bulbs. Yeah, it doesn't like that. So don't take that short circuit in there. So until you have 2 bulbs, you can only have a single loop. And once you've got the 2 bulbs in here, then you can actually make it parallel. Otherwise, it's going to be all angry at you. Okay. So there's that. And then make a rule. And then you're going to take a guess and extend your thinking. Okay. Do some calculations using Ohm's law, using some of these formulas here. And finally, what you're going to end up turning in, remember, is not any of these. You are going to go to this sheet here and transfer some of your answers onto this sheet. So this is just for series circuits, just for parallel circuits, and then conclusion questions, which kind of wraps them both up. I do expect at least single, if not a couple sentences here, and I expect full paragraphs here, okay? That's all I want, though. If you don't turn the other sheet into me, I'll send it back, okay? And if any questions, just call me or send me a webmail, and I would be happy to get in touch with you and answer the questions. Hope you have a great day, everybody. Talk to you later.